Hey everyone, in this session we will understand a very important concept called model persistence. Model persistence is a process of saving a trained model for further use. So far in all our previous sessions we have seen how can we create a model, train the model with the help of training data, and how we can predict the outcome with the help of well-trained model. Now, unless we are saving the well-trained model somewhere, every time we want to use the model, we have to train it. And for an enterprise level machine learning problem, training takes a lot of time because we use complex model and a huge amount of training data. The process of saving the trained model object into a binary file called model persistence. Saving and reloading trained model saves a significant amount of training time. Persisted trained model can easily be reused or deployed to multiple environments. These are the very important advantage, and that is the reason it is very critical for us to save the trained model into our secondary memory. Pickle and joblib are two very important and well-known libraries to save a trained model into a binary file. We can serialize or save a machine learning model either with the help of pickle or with the help of joblib. If we are using pickle, we can open a file in write binary mode and save the model with the help of pickle.dump method. What will happen? Our trained model was in primary memory or RAM. With the help of pickle.dump, we can save it in our secondary memory as a binary file. Similarly, joblib also gives us joblib.dump method, which takes model and the file name to save the model as a binary file. Any one you can use. However, the best practice is whenever you have a number of NumPy arrays in your model, you will be using joblib over pickle because joblib optimizes the NumPy arrays better than pickle. Once we have created the binary file for a trained machine learning model, we can share this file among different environments from one project to other. Anything can be possible. That means you have created a portable version of your machine learning model, which is already trained. Next time, whenever you want to use this model, you don't have to train the model with training data. You can directly use this trained model to predict your outcome. Let's understand how we can deserialize or load a model in order to use it to predict the outcome. You can use pickle library to read the file and create the model out of it with the help of pickle.load. What it does, it takes the binary file from your secondary memory and then it loads it into your primary memory, and you are ready to use this model for your prediction. Joblib also has load method which takes the file name and it loads the trained model within this model object. Hope you have realized what is the meaning of serialize or save a machine learning model and when to deserialize or load the machine learning model. When we want to save the model into our secondary memory, we serialize it so that the trained model object converts into a binary file and we keep it for our future usage. And whenever we want to use that trained model for our prediction, we do deserialize or load the model into our primary memory. Let's jump to Jupyter Notebook and understand it with an example. In this example, we have imported few libraries and we will be predicting the digit based on the grayscale image. We are using pandas for data preparation. We are importing support vector classifier. If you are not aware about support vector classifier, I have a dedicated video for support vector machine. You can go through it. The video will be in the same playlist. We are using sample digits dataset from sklearn, and we all know what is train, test, split method of sklearn and why to use it. We are loading digits data. This data has all the independent columns. In this case, independent columns are nothing but the pixel value for a 8x8 grayscale image. Feature names has the pixel numbers or the independent column name. Target has the corresponding number for a specific image. Let's import matplotlib and then see how the image looks like. This is the grayscale image we will take as input in our machine learning project, and our target is to identify the corresponding number from 0 to 9 which is present in this image. In this case it is 1. We are creating data frame for our feature columns or the independent columns. As you can see here, we have 64 columns and each representing 1 pixel of this grayscale image. Let's create the target data frame. Target data frame has the corresponding digits. So basically we will provide the value of 64 pixels and our model will predict the corresponding digit out of it. We are splitting the entire data set into xtrain, ytrain, xtest, ytest. We will be using xtrain and ytrain for training the model and xtest, ytest to test the model. We are creating CLF, which is nothing but the model object of a support vector classifier. We are also setting corresponding hyperparameters to it. If you are not aware about hyperparameters and what is hyperparameter tuning, we have another video for it which is available in the same playlist. Let's create the model. Now it's time to train the model. With the help of model.fit and passing xtrain, ytrain, we can train the model. Once we have the trained model, we can use it for our prediction. Here we are only providing 5 rows of independent columns and our model is predicting corresponding digits. Let's see what is the actual digits it has in ytest and we will match it with our prediction. So our predicted values are exactly same as the dependent columns in test dataset. If we want to check accuracy, we can use score method. Our model accuracy is 96%. Now, if we stop here and then close the project and reopen this project again, our trained model will be lost. Again, we have to create a new support vector classifier, train that model with the training data, then only we can use it for our prediction. That means training the model is a recurring task or a prerequisite task before using that model for our prediction. To solve this problem, what we can do? We can save this trained model in our secondary memory as a binary file, so that as and when we need prediction with the help of this trained model, we can just load it and run predict method with that model without training it again. 2 ways to do it. Option 1, we can use pickle library for saving the model. How can we save it? We can create a binary file with a specific name and we can use pickle.dump to create the binary file out of a well-trained model. So the model object will be converted into a binary file with the help of pickle.dump. Let's run this. This will create svc_model file in our secondary memory or hard disk. Let's see the content of the file. The content of the trained model is something like this. It is showing lot of special characters and some gibberish because it is not a text file but a binary file. Now, how can we use the trained model what we have saved earlier? We can open the file in read binary mode and load the file into a machine learning model. If we run this, it converts the binary file into a model object here. Let's see if we are getting back the exactly same model what we have saved earlier. Last time our model accuracy was something like 0.96. Let's see if we are getting the same score this time as well or not. We are getting same score as we get last time from our trained model. This proves that we could successfully save the trained model into a binary file. Now we can use the same model and we can run predict method on top of it. We don't have to retrain this model to make it a trained model for prediction. Similar to pickle, we can also use joblib library of Python to perform the same operation. joblib.dump converts the trained machine learning model into a binary file. Now we can pass this pickle file to any other machine or any other server, even in cloud, for our usage. When we want to use it, we have to convert that binary file into a model object again. joblib.load does the same thing. It takes the file name and converts it into a model object. Sometimes we face some issue if we are using a saved model with a different version of sklearn library. For example, if you have created a trained model in a specific sklearn library version and want to run the same model into a different environment where sklearn library version is different, sometimes it will give you the compatibility issue. Hence, the best practice is to save the model with corresponding sklearn library version. It will help us to understand what is the sklearn library version with which we have created this trained model and saved it in our secondary memory. So it's a best practice to save the model with sklearn library version number. How can we get this? We can get sklearn library version with the help of sklearn.version. In my case, it is 1.4.0. So whenever we will save the model, we will use the same version in our file name, so that anyone in future can easily identify that the model has been created with a specific version of sklearn and the version is, in this case, 1.4.0. Now whenever we will reload the trained model, we will use joblib.load and then model underscore 1.4.0 dot pkl, the exact name how we had saved that model, and then use it for our prediction. If you see, in this case also the score is exactly same. Hope you have enjoyed this quick and important session. Thanks a lot for watching this video.